right, in this new unit, we are going to be solving systems. So we've solved equations and we've graphed equations. So we're going to be combining those two things, starting off with solving these systems by graphing. So normally, let's look at this first example. We would only have one line on our graph. Now we are going to be talking about two lines, two equations, and figuring out the solution. So looking at this example up above, we could have three different things happen on a graph. We could have those two lines crossing, just like this is in this picture, at one point. So wherever that point is, that would be our solution, that point where the lines cross. So if you want to write that down with me, we're looking for the point where they cross. Now, what if those two lines don't cross? Just like in this picture right here. So if they do not cross, that is when we have no solution. And we would say that, we would write that as our answer. Now this last picture is kind of weird to look at. If you look very closely, there's a blue line on mine, and then underneath it, there was another line. Those two lines are one on top of the other. So one line on top of the other line. That is what we call infinitely many solutions. Those lines are crossing here and here and here and here and here and here. They have all of the points are crossing. So these are the three different types of solutions that we could see when we are graphing systems of equations. So let's look at example 1. It looks like if you scroll down or look down, we have two lines already graphed, which is super nice. So we can see they are crossing right here. That is the point 3, 2. Make sure you're being careful when you name your points. It was 3 on the X and 2 on the Y. So our solution to that system is 3 over 2. That would be our answer. 3, 2 is the solution. All right, let's turn our page and look at some more examples. All right, example 1. They haven't graphed it for us yet, so let's graph it. We've gotten really good at graphing. So on the first example or equation, it says y equals -2x minus 4. So I'm going to begin at -4 on my y-axis. And I'm going to count my slope. It was -2. So we are going to go down 2, and it had nothing divided by it, so it's divided by 1. So I'm going to go down 2, right 1. Down 2, right 1. As far as you can go. Now remember, we're looking for where these lines cross. So I would make as many points as you can so you can find that exact point. Do not be lazy and not plot all those points. Okay, so we went down to right 1. We're going to do the opposite and go up to left 1. As far as you can go, make every single point on your graph that you possibly can. So now that I have all my points, I'm going to draw my line. And I'm going to switch colors for you so you can see the difference between these. I'm going to start on my red line now. So that equation looks like my b is 6. So I'm going to begin on my y-axis at +6. And my slope is 1 over 2. So positive 1, I'm going to go up 1. Positive 2, I'm going to go right 2 as far as I can go. Up 1, right 2. Up 1, right 2. Looks like I ran out of room, so I'm going to go the opposite direction. I'm going to go down 1, left 2. Down 1, left 2. And look at that. Our lines crossed exactly on that point. Let's keep it going though. Down 1, left 2. Just to be very specific on our graph. Very straight lines. And I'm gonna make my line, put my arrows on the ends. So since I have one point where they crossed, I have one solution. And that one solution we need to name as a point. So that point, if you need to look up closer, it was -4 on the x and +4 on the y. So that point would be -4, +4. All right, let's try another example. Example 2. Example 2 looks like we need to solve for y on some of these. So let's do that. Let's look at the first equation. I'm going to do this one in blue again. I need to solve for y, which means I need to either add or subtract the x. It looks like it's a -2x, so I'm going to add 2x to both sides of that equation, leaving me with y equals, and I cannot put 6 plus 2x together, so I'm going to leave it 6 plus 2x. And I have y all by itself, so we're going to take it to the graph. This looks like it. This is our m, and this is our b. So we are going to begin at 6 on our y-axis. And our m was 2, or 2 over 1. So I'm going to go up 2, right 1. As far as I can go. Didn't have a lot of room, so I'm going to also go the opposite direction. Down 2, left 1, as far as I can go on my graph. Down 2, left 1, down 2, left 1. Now that I have that lovely line, I'm going to connect my dots and focus on my second equation. I'm going to do my second one in red just so you can see the difference. All right, need to start off by solving for y. Looks like I need to move the x first by either adding or subtracting. So since it's a -4x, I'm going to add 4x to both sides of my equation, leaving me with 2y equals, I cannot add these, 8 plus 4x, so I'm going to leave it 8 plus 4x. I still don't have y alone, so I need to get rid of that 2. It's a 2 times y, so I'm going to divide by 2 on both sides of the equation. Make sure you do this division. We need to do 8 divided by 2, giving me 4. And then I also need to do 4 divided by 2, which is +2. All right, let's take that to our graph. It looks like my m is 2, or 2 over 1, and my b is 4. All right, so I'm going to begin at 4 on my y-axis, and I'm going to count my slope, 2 over 1, so up 2, right 1, as far as I can go. Once I run out of room, I'm going to do the opposite and go down 2, left 1. As far as I can go, down 2, left 1. Looks like I made all my points I possibly can, so I'm going to draw my line and connect. Put those arrows on the end. Looking at these two graphs, it looks like I have nowhere where they cross, which means I have no solution. All right, let's look at another example. Flip your page when you're ready. Example 3. We need to start by graphing, so I'm going to graph this first one in blue, and it looks like it's already solved for y, so I can go straight to my graph. My b is 9, so I'm going to begin at positive 9 on the y-axis. And my slope is hiding. It's a -1, or a -1/1. So I'm going to go down 1, right 1, as far as I possibly can go. Looks like I ran out of room, so I'm going to do the opposite and go up 1, left 1, which I only can do once, which is okay. But I want to make all the points I possibly can on my graph to really see where those lines are crossing. All right, going to the second equation. It looks like I need to do some solving for y. So I need to get rid of that 2 that's by the y. To do that, I'm going to divide both sides by 2. So I'm going to do some division. I'm going to do -2 divided by 2, which is a -1. Don't forget the x. And then I'm also going to do 18 divided by 2, which would be +9. Let's take that to our graph. We're going to begin at +9, and we're going to count our slope, which is -1, or -1/1. So I'm going to go down 1, right 1. Down 1, right 1. Wait a second. This is exactly the same line. These two lines are lying one on top of the other one, which means all of the points are where they are crossing. And in math, we call that, if you want to write the fancy symbol, infinitely many solutions. You can go to practice this on Delta Math. It is under Unit 4, Solving by Graphing.